In the previous class, you discussed solid state. Solid state. In the previous class, you discussed solid state. Today, we are going to discuss liquid state. Liquid state. Okay. What are liquids? Some liquids. I am going to give some liquids. Examples for some liquids. H2O. H2O is liquid. Ethyl alcohol is liquid. C2H5OH. This is called ethyl alcohol. C2H5OH is called ethyl alcohol. And benzene C6H6 is called benzene. Here L represents liquid. L denotes liquid. Benzene, liquid. Similarly, carbon tetrachloride, liquid. Carbon tetrachloride is liquid. Okay. Carbon disulfide is liquid. These are the liquids. Okay. Some examples I have given you. Some examples for liquids. Okay. What are the properties of liquids? Liquids have larger intermolecular spaces. First point. Liquids have larger intermolecular spaces. Larger intermolecular spaces. And the intermolecular forces between liquid molecules are weak. So, weak intermolecular forces. Weak intermolecular forces. Weak intermolecular forces. Weak intermolecular forces. Weak intermolecular forces are operating among the liquid molecules. But in case of solids, strong intermolecular forces operating among the molecules. And next, liquids do not have definite shape. Liquids do not have definite shape. Solids have specific shape. Solids have definite shape, specific shape, cube, face-centered cubic structure, body-centered cubic structure. Okay, but liquids do not have definite shape. Liquids occupy definite volume. Liquids occupy definite volume. Liquids occupy definite volume. Okay, next. Liquids are slightly compressed. Solids do not undergo compression. When a pressure is applied, the shape of solid does not change. But in case of liquids are slightly compressed. Liquids are slightly compressed. Liquids are Slightly compressed. Slightly compressed. Okay. Next, property of diffusion. Liquid molecules diffuse easily. Liquid molecules, for example, ethyl alcohol, petrol molecules or ethyl alcohol molecules can diffuse from one place to another place. So liquid molecules diffuse easily. Liquid molecules, liquid molecules diffuse easily. What is meant by diffusion? What is meant by diffusion? The movement of molecules, the movement of molecules of a substance from one place to another place is called diffusion. Gases are easily diffused. Solids do not diffuse. That's why solid molecules are held together by strong electrostatic forces. But liquid molecules are diffused easily. Gases have more diffused. Gases have more tendency to diffuse from one place to another place comparatively solids and liquids. Next point, the force of attraction among the molecules of the liquid is known as cohesive force. The force of attraction, the force of attraction, these are the liquid molecules. These are the liquid molecules. The force of attraction between any two molecules, any two liquid molecules is called cohesive force. Cohesive force. Cohesive force. So, cohesive force is operating among the liquid molecules. Okay, these cohesive force are weaker forces, are weak forces. In solids, molecules are held together by strong forces. Comparatively solids, the forces among the liquid molecules are weak. The forces operating among the liquid molecules are called cohesive forces. At the same time, adhesive forces, adhesive forces, adhesive forces. What are adhesive forces? When a liquid is placed in a glass or when a liquid is placed in a vessel, the force is operating between molecules of liquid and molecules of vessel, molecules of a solid vessel. That's why liquids are stick to walls of container. When liquids are placed in containers, liquid molecules are stick to the walls of container because of there are adhesive force is operating between liquid molecules and solid molecules of the container. Okay, so adhesive forces are dominated by our cohesive forces. Cohesive forces are operating among the liquid molecules. Yes or no? Adhesive forces are operating between liquid molecules and the molecules of the solid container. Adhesive forces dominated over cohesive forces. That's why liquids are stick to the walls of container. Okay. These are the properties of the liquids. These are the properties of the liquids. Next, gaseous state. Gaseous state. What are the examples for gases? Some examples, some gases are nitrogen, oxygen, fluorine, chlorine. Okay, these are the gases. Helium, neon, argon, krypton. Okay, carbon dioxide, carbon monoxide, sulfur dioxide gases. What is the main difference between solid state and liquid state and gas state? In a solid state, the distance between molecules to neighboring molecules is very less. But in a gaseous state, the distance between two molecules is very large. Is very large. So gaseous molecules have gaseous molecules have or gases have larger intermolecular spaces. So gaseous molecules arranged as like this. Gaseous molecules are arranged as like this. The intermolecular spaces between gases have larger intermolecular spaces. The distance between two molecules is very large. Is very large. The distance between two molecules is very large in case of gases. That's why intermolecular forces are weak and gases have larger intermolecular spaces. So the first point is gases have gases have larger intermolecular spaces. Larger intermolecular spaces. Larger intermolecular spaces. Next point. Gases have very weak intermolecular forces. Gases have very weak intermolecular forces. Very weak intermolecular forces. Gases are diffused. Gases are easily diffused. Okay. Next, the volume of the gas is equal to the volume of the container. Gases have no specific shape. Gases have no specific shape. Next point, the volume of gas is equal to the volume of the container. The volume of the gas is equal to the volume of container. Okay, next, gases are highly compressed because the intermolecular distance between gaseous molecules is very large. When pressure is applied, gas is easily compressed. So gases are easily compressed. Okay, gases are easily compressed. These are the properties of the gases. So every substance can exist in three states: liquid state, solid state, and gas state. Depends upon the temperature. So you have discussed the properties of the solids, properties of the liquids, properties of the gases. So in case of solids, the distance between molecules is very less. But in case of gases, the distance between molecules is very large. Solids do not compress. Solids do not compress, but gases are easily compressed. Gases are easily compressed. Okay, next. Interconversion of interconversion of interconversion of one state to another state, one state to another state. And first one is freezing point. Freezing point. What is the freezing point? Take water. Take water. Okay, when water loses its heat energy, okay, when water is placed in deep freeze in a refrigerator, what happens? Water loses its energy. Water loses its energy. Water molecules are moving. Water molecules are moving. When water is cooled, the movement of water molecules and the velocity of the movement of water molecules is decreased. So water molecules loses kinetic energy. Water molecules are moving. Moving molecules have kinetic energy. When water is cooled, the velocities of water molecules are reduced. So water molecules loses kinetic energy. When kinetic energy loses, temperature decreases. Okay, temperature decreases. So when water is placed in deep freeze in a refrigerator, water loses heat energy. So all water molecules are come close together. All water molecules are come close together, and liquid water is converted into solid water. Solid water. This water is called ice. This water is called ice. The temperature at which liquid water is converted into solid water is called freezing point. That is freezing point. This is equal to melting point. This is equal to melting point. Okay. The freezing point or melting point of water is 0 degree centigrade. 0 degree centigrade. Different liquids have different freezing points. The freezing point of water is 0 degree centigrade, but the freezing point of benzene is not 0 degree centigrade. Different liquids have different freezing points. All liquids do not freeze at the same temperature. Different liquids have different freezing points. Okay, freezing point also depends upon the impurity. When impurity is added to the water, its freezing point is decreased. For example, water is purest water freezes at 0 degree centigrade. When NaCl is added to the water can't freeze at 0 degree centigrade. Water will freeze below 0 degree centigrade when NaCl is added to the water. Okay, in the presence of impurity, the freezing point of liquid is reduced. The freezing point of liquid is reduced. Okay, so during freezing, loosely packed molecular structure is converted into loosely packed molecular structure is converted into closely packed molecular structure. During freezing, during freezing, freezing, loosely packed, loosely packed molecular structure, molecular structure is converted into closely packed, closely packed molecular structure, molecular structure, molecular structure. Okay.